So now we're going to do section 2.3. We're skipping section 2.2. So now we're on 2.3, and this is about lines. So in this section, we're going to find out how to determine the slope of a line, sketch a line given a point and the slope, find the equation of a line using point slope form, and find the equation of a line using the slope intercept form. Okay. Yeah, we're going to do all this. Write the equation of a line in standard form. Find the slope and y-intercept of a line in standard form, sketching lines by plotting intercepts, and finding the equation of a horizontal line and a vertical line. So this one, I just want to point out, this one right here, when you're given a problem in the software and it says, plot the points by using the intercepts. What that means is, or sketch line by using the intercepts, that if you put any other 2 points on the graph and connect them in Pearson, they're going to mark you wrong. You literally have to find the x-intercept and the y-intercept, and those are the 2 points that you're going to connect to get your line. Okay. So what does the slope mean? So if x1 is not equal to x2, so I have 2 different values of x. Of course, I have to have 2 different values of x, or I'd have 0 in the denominator. If I have 0 in the denominator, it's undefined, right? The slope of a non-vertical line, so this is not vertical or horizontal, passing through those 2 points is given by, so basically we use m for slope. And the easiest way to think about it is the rise over the run, because you can see that we are rising. And when I run, I don't run up, I run across. So we call that the run. Okay. So we're always looking for the change in y over the change in x, the rise over the run. And the change is going to be the distance between those 2 points, right? Because you can even see it here. Y2 minus y1 would give you the length of that line. And x2 minus x1 would give you the length of that line, okay? And the distance formula would give us the length of the red line between those 2 points, even though that's not what we're talking about anymore, okay? But the slope is always y2 minus y1 over x2 minus x1. If you think about it as rise over run, that should help you. Rise means I'm using the vertical axis because that goes up, and horizontal is the run, okay? So if we have, it says find the slope of the line that passes through the indicated ordered pairs. So for this, I'm going to call, actually this time I'll do it different, because again, it doesn't matter what I call what point. Okay. So I'll call this one 2 and I'll call that one 1, which makes this one x2 comma y2 and this x1 comma y1. You could do it the other way. Again, it doesn't matter, okay? I'm going to say the slope is equal to the distance in the y direction, the rise over the run, okay? And so y2, well, we just said that was 1 minus y1 is -4 divided by x2, which is -5. Oh, I think I just did it backwards. Yep. See? Sorry about that. Let's do it again. So I changed this one to 0.2. So y2 is now -4 minus y1 is 1 divided by x2, which is 6, minus x1, which is -5. So I'm just taking now I can just take the points right from there, and I don't have to do anything else. I just have to know the slope of a line. So -4 minus 1 is -5. divided by 6 minus 5 is the same as 6 plus 5, which is 11. So the slope of my line is -5/11. Now, I also would like to show you that if you graph that line, it's going to have a certain, it's going to go, oh, I'll show you. So 6, -4. So let's go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So here's this point. That's the first, that's the second point actually. And -5, 1, 2, 3, 4, 5, comma 1. So that goes here, right? And this, and let me see if I can do a decent job connecting those 2 points. The slope of the line measures the incline, okay? Now, if you notice, and of course, we're always reading these lines from left to right, okay? So when I talk about whether something's going up or something's going down, when I read a book, I look from left to right. When I read a graph, I go from left to right. And I can see that if I go from left to right, this line is going down, right? And it's, so I know that that means my slope is got to be negative. If my slope is positive, my line will be increasing as I go from left to right. So I can't tell you if this is exactly the right answer, although I'm sure it is, but I can tell that at least it's got a possibility. If it came out to +5/11 and I drew the line, I could tell right away that that slope would have to be positive, because, or the number that I have is wrong, because a +5/11 and a graph that looks like that would not work. If I had a positive slope, and I'm just making up a line, it would go like that. This has a positive slope. It's going up if I look at it from left to right. Okay. All right. So now it says sketch the line, and it's telling me the slope that passes through the, and it's telling me a point on the slope. And it says also find 3 more points located on the line. So basically, we're going to start with sketch the line with the slope. So here's how I'm going to start. And this is really probably the easier way to graph lines. I mean, I guess it does depend on what information you have. So this is -4. So I have this point, right? And let me put in some more numbers here. 1, 2, 3, 4. I don't know how far I have to go. 1, 2, 3, 4. I don't know if this is good enough, but we'll see. So remember we said the slope is equal to the rise divided by the run. Not the rum, the run. Okay, and remember, we found our point that they give us. So, and it's positive, okay? Because if it's negative, it means something different, but it's positive, which means I'm gonna go up. Here, let me do it like this. I'm gonna go up 2, and I'm gonna go, because that's the rise, right? And then I'm gonna go over 3, because that's the run. And so my point would be right here. Notice that if I'm going up 2, because the rise is equal to 2, then if I start here at -4, I count 1, and then I count 2. So it's at -2. And then I go to the right 3 because it's positive. 1, 2, 3. And now I connect those dots. And that I have now sketched the slope of the line that goes through those two. I've sketched this, I've sketched the line with the slope of 2/3 that goes through, that passes through the point. I did it again, did the same exact thing. But I think I can make this one work. Here's -1, 4, -4. Sorry about that. But it doesn't matter. It's still the same. Okay? It's still -1, -4. So also find 3 more points located on the line. Well, to do that, it's really hard to do with a sketch. So what I'm going to do is I'm going to turn it into an equation. And we haven't seen this equation yet, but we will right now. So every line can always be put in the form y = mx + b. This is called slope intercept. Okay, so what that means is we have m is equal to the slope, and b, whatever b is equal to the y-intercept. Okay, because if I put in x = 0, mx disappears, and I just get y = b, which is the value when x = 0, which is the y-intercept. Okay, so, well, here's the only problem with that. I don't actually have the intercept. So how can I do it? Well, there's another equation, which we're going to learn in a little bit, but I'm going to show you right now because I actually think that it's the way I'm going to show you is a better way to do it. So this is slope intercept. I also have one called point slope. And when do you think would be good to use point slope? Well, when I know a point, which I do, and I know the slope, then I use point slope. And basically point slope says that if I have y minus y1, which is my point, y1 is the point, is going to be equal to the slope times x minus x1. And if you divide both sides by x minus x1, notice you kind of have the slope formula, right? So we're just kind of changing the look of it. So if I want to find the equation of this line, well, this is going to be for us y minus, and y1 is -4. Because that's the only point I have. I don't have a y1 and y2, I only have a y1. And that's going to equal m, which they gave us, times x minus, and x1 is -1. So now I have y + 4 is equal to 2/3 times x + 1. And I can subtract 4 from both sides. And now I know y equals, well, first of all, before I subtracted it, that's point slope. We will be going over point slope again, don't worry. But I'm going to solve for y just so I can find the other 3 points. So I have 2/3 times x + 1 minus 4 equals y, right? And then let's do 4 points. So I'm going to make a little table here. So here's x, here's y. And let's plug in some numbers. So if x = 0, y equals So I have 0. Here, let's do it like this. I'll do it here. So y equals 2/3 times 0 plus 1 minus 4, which is equal to 2/3 minus 4. You can use your calculator, but if we're subtracting two numbers and one of them is a fraction, then we consider both of them fractions. So you can call this 4/1. Common denominator is 3. So I'm going to multiply this by 3/3. And what I get is 12/3. And let me put it together. 2 minus 12/3 equals -10/3. So now I have 1 point, right? That's all I have is 1 point. When x is 0, y is -10/3. And then I can just do the same for another number when x equals 1. And I'm going to use the same space. So just go back and pause it or whatever you need to do if you wanted to write down what I'm erasing here. But I'm going to use just this area right here to calculate. So I have, again, y equals 2/3 times, well, this time I said x is 1. 1 plus 1 is 2 minus 4. So this equals 4/3 minus 4. Again, I'm going to turn this into a common denominator. So I'm going to make 4 into 12/3 by multiplying by 3/3. And I get y is equal to -8/3. So when x equals 1, y equals -8/3. And then, just pick another number. It doesn't really matter. You want to pick a negative number? We can pick a negative number. Let's pick -3, okay? So when x equals -3, I have y equals 2/3 times -3 plus 1 minus 4, which is equal to 2/3 times -2 minus 4, which equals -4/3 minus 4. Again, I'm going to change the 4 into 12/3. So we have -4/3 minus 12/3, which equals -16/3. So there's 3 new points. And I wouldn't write it, I would have to write it out like this: x, comma, y. That's for the first one, right? X, comma, y. X, comma, y. That's usually the way they want it. You just have to read underneath all the answers to see exactly what form they want it in. You always want to read what the form is that you have to put things in. Sometimes they want a fraction, sometimes they want a decimal, sometimes they want an ordered pair, sometimes they want just a value. You underneath just read the directions. Okay, so here's point slope. And again, I gave you this equation. And it really comes from, if we know that the slope of a line is m equals y2 minus y1 over x2 minus x1, and I multiply both sides by x2 minus x1, right? These are going to cancel, and I'll have m times x2 minus x1 is equal to y2 minus y1. Now, the only thing wrong with this is this is saying I know two different values of X, but they're only giving me 1 point. So I only know one value. The other one is variable. So I change it from that to the X2, since we don't have an X2, I change it to just X minus X1, because I know X1 equals, and then I don't have a Y2 again, so I have Y minus Y1. And I know that I will be given X1 and Y1 because I'll be given 1 point and I'll have the slope. That's why I want to put it into point slope. Okay, so let's do some problems. So we want to find an equation in point slope form of the line with slope m equals 2/3 that passes through the point -1, -4. Now it's really easy because I have a point and I have the slope, and I know that y minus, and this is x1 comma y1. So I have y minus -1. Nope. That's my x. Sorry about that. Keep making mistakes. I'm sorry. So we have y minus -4 equals m. So y minus y1 equals m times x minus x1. So I have m, which is 2/3, times x. I don't know. I only have one x, and the one x that I have is -1. I simplify. I get y plus 4 is equal to 2/3 times x plus 1, and I'm done. This is the answer in point slope. Okay, here's my point, and here's my slope. This is y1, and this is x1. Of course, it's negative. It's changed to positive because originally the format is negative. Okay, it's really not that hard once you understand how to do it, and they give you the right information. Slope intercept, that's y equals mx plus b. Most of you have seen this before, where m is still the slope and b is the y-intercept. This is the slope. And it says it up there. So if you're asked for something in slope-intercept form, well, you need to know the slope and you need to know the y-intercept. And then that's an easy thing to do. You can even change point slope into slope-intercept by just solving for y, because that's all the difference is, okay? All right, so find the equation of the line with slope 1/4 and y-intercept 3. Well, we start with y equals mx plus b. I'm being told that the slope, or m, is equal to 1/4, and I'm being told that the y-intercept, so this is the slope, and I'm being told that b, which is the y-intercept, is 3. I'll just write here, this is the y-intercept. And now I plug things in, which gives me y equals 1/4 times x plus 3. And I had someone who came to office hours who was a little confused about this, but this is exactly the same as x over 4 plus 3. So 1/4 times x is the same as x over 4, because x is really the same as x over 1. When we have two fractions and we multiply them, that we multiply the numerators and then we multiply the denominators. So this is the answer. They're both exactly the same. And whichever one you want to, whichever form you like better, use it. Okay, now we have our final form for a line. So the final form is called standard form, and it's ax plus by plus c, where A, B, and C are real numbers. So A, B, and C are real numbers such that A and B are both non-zero. And actually, there's one more piece that they didn't write here. A, B, and C are integers. And integers are whole numbers. So integers are, for example, if I were to write a set, would be dot, 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 means it's going all the way to negative infinity. And then I would have like -3, -2, -1, 0, 1, 2. And then it just keeps going on to infinity, right? Those are integers. They're whole numbers. They're not fractions. So that's where some of you may make a mistake. That's why I'm pointing it out. It's there. I don't really like the way they say it in this slide because they're integers.